Hi, in this video, I'm going to talk about some of the review of confidence interval and one sample hypothesis testing. Okay, you remember that in your statistics, elementary statistics class, you learn how to find out area under a normal curve, how to find out critical values, and how to find out the confidence interval, how to find out how to test a hypothesis for mean when a standard population variance is given, when population variance is not given, the confidence interval and the hypothesis testing for the proportion for variance and so on. So I'm going to do a short review of those first, okay, and then we will do the confidence interval and the hypothesis testing for two samples later. Okay, guys. All right, so let me go through the review. The first thing you learn is standard normal distribution and the area under Z curve. Okay, so what we did there is, suppose you have a standard, so suppose you have, let's say, this is a normal distribution, right? Standard normal distribution is 1, that has a mean is 0 and standard deviation 1. Okay, so mu equals 0, sigma equals to 1 is called the standard normal distribution. Okay, so how do you find out the area under something, above something, or between two numbers like that? So that is area is same as the finding the probability, right? If you say this is G curve, okay, this is G standard normal, okay, and then G is less than, say, 0.41. If you want to do that, so what it is saying, it is saying that you want to know, so this is 0.41 will be right side because the right side of 0 is positive numbers, left side of the 0 is negative numbers, right? And then you are trying to find out all this area, you see that, all those area. So how to find out that area left of 0.41? So this is 0.41, right? So how do I do that? Is basically you can use R for that. It is P norm and then 0.41 and then 0,1. That means the P norm is actually it finds the area under the standard normal curve, right? Area under the standard normal curve. And then left of that. So actually R finds the area left of, let me do it here. Let's say, what is that value? P norm and then 0.41 comma 0 comma 1, mean is 0, standard deviation is 1. If you run this, what do you get? You get oh, by the it is 0.41, right? 0.41. So this is what you get, right? 0.6591. So this is what you get. So this is 0.6591. This is what you get, right? So, but if you want to find out the area right of that, so what will be the area right of that? This is the area right of that, right? So if you want to find out the area right of the 0.41, we denote by PG is greater than 0.41. Okay, this is the area right of that. So how do I find out that? P norm always finds the area left of a number, of that number. That's what the P norm does. P norm always finds the area left of that number. So if you want to find out the right area, what you can do is you can do equals to 1 minus P norm area left of 0.41, right? So you can do P norm and then 0.41, right? And then 0, 1. What is that? So this will find out the area left. And if you subtract from 100%, then it will give you that value, right? So how much would that be? That will be 1 minus P norm, right? So 1 minus P norm 0.41 and then 0 and then 1. If you do that and if you run this, what do you get? You basically get 0.3409. okay, so that is 0.3409. This is how you find out the area or the probability. Now sometimes you are asked to find out the critical values. How do I find out the critical value? Is actually I covered this in the I think it was in lab 2. Okay, I'm just giving you a short review on that. Suppose you have just a normal distribution. This is a standard normal curve, right? So if you have just a normal curve will be it will be a bell-shaped curve, but the mean and standard deviation need not to be 0 and 1. Okay, so it may be like, let's say mean is something like mu equals to 25 and then sigma equals to 2. It can be like this. Okay, so how do you find out that? Is basically, oh, by the way, so how do you find out if you are asked to find the area between the two values? For example, let's say if you are asked to find out the area between, let's say these two values, let's say g equals to negative 1.2 and then 0.41. So how do you find out that? Probability that negative 1.2 is less than g is less than 0.41. How do we do that? You just do p norm of this, that will find out the whole thing, minus p norm of 1.2, right? So you will do p norm of 0.4101 minus p norm of negative 1.2 and then 0 and then 1. If you do that, what do you get? Your answer will look like, let me find out here actually. Let me find out here. So what you get is p norm is 0.41, right? And then comma 0 comma 1 minus p norm is negative 1.2 comma 0 comma 1, right? So if you run this code, what do you get? You basically get the value is 0.5440. That you will get 0.5440. That's what you get. Okay, so this is the case of the standard normal. Now if you have just the normal, that means the mean and standard deviation are not 0 and 1, then you can still do that thing. But what you do is you need to do p norm to find out the area left of certain values of x. Let's say x equals to 28. Okay, so if you want to find out the value, this value, so what is that? Probability that instead of g, without x now, right? So x is less than 28. So what is the probability that x is less than 28? Or what is the area left of 28 if the normal distribution has mean is 25 and standard deviation is 2? So in that case, what you do is p norm. Again, p norm will find out the area left, right? So you do 28 comma, what is the mean is 25 and then it will be 2. That's what you get. Okay, so how much do you get? The area there, it will be, let us do that. If you do that, you will get p norm and then left of 28, you want to find out the area left of 28 and mean is 25 and then the standard deviation is 2. Okay, if you run this, you get 0.9331. So that will be 0.9331. Similarly, you can find out the right area. How do I find out the right area? So the right area, let's say area right of 1.28. Let's say you want to find out that. Okay, so what do? You do 1 minus p norm and then x is less than 28. You do that. Okay, and then use r to find out that. It will be 1 minus p norm, right? So you do 1 minus and then control V, control C and control V. It give you 0.0668. 0.0668. Similarly, you can find out the area between the two values. So you can do that yourself, okay guys. But if you have a t distribution, so t distribution depends on the degrees of freedom, okay? So t distribution, so if you have a t distribution and if you are asked to find out that instead of p norm, you do pt, okay? So and then degrees of freedom, okay guys. So for example, let's say this is a t distribution with mean 0 and standard deviation 1. So you see that when the sample size is different, then it depends on that sample size. For example, if you want to find out, let's say 1.1, what is the total area or the probability okay, under the normal curve, what is the area that t is less than, probability that t is less than 1.1? What do you do is equals to pt and then 1.1, and then let's say the n equals to, let's say 20, okay. So the degrees of freedom will be 19, because degrees of freedom will be n minus 1, okay. So that will be 19, and then you find out that area. Similarly, if you want to find out the right area here, if you want to find out the right area, again do the same thing. You can do 1 minus and then pt and then 1.1 and then 19 will give you those values, okay. So what do you get if you do that? Let us say that, okay. So you will see, let us say that, okay, you will see pt and then 1.1 and then 19 degrees of freedom, right? That is the one, and then another one will be 1 minus pt and then 1.1 and then 19 degrees of freedom. So if you do that, you will get, the first one is 0.8575, so that will be 0.8575, and then the second one here is, if you run that, you will get 0.1425. So 0.1425, okay. So 0.1425, this is what you get. Similarly, if you want to know the area between the two curves, okay, suppose you want to know the area between the two curves, let's say area between the two t values. So like this, if you want to know these values, what do you want to do? Let's say this is negative 0.6, okay. In that case, how do you find out that? It will be, by the way, this one is probability of t greater than 1.1, right, equals to that. So if you want to have p negative 0.6 is less than t is less than 1.1, you find out the total area left of 1.1 by pt, 1.1 19 degrees of freedom minus pt and then negative 0.6 19 degrees of freedom, okay. You will do that, and then what do you get there is, you can do pt, right, 1.1 and then 19 degrees of freedom, right, and then minus and then pt negative 0.6 and then 19 degrees of freedom. If you run this, what do you get? That is the area, 0.5797, okay, 0.5797. This is what you get, okay guys. So this is how you find out the area under normal curve, and then area under the t curve. It is also the like symmetric, okay, symmetric curve, but it may be little different shape there, okay. All right, it is also a symmetric curve. Okay, so the next thing I want to do is I want you to show how to find out the area under a chi-square curve, okay. For example, suppose you have a chi-square distribution. Chi-square distribution is the right tail, right? So it is like this. So chi-square distribution will be like this, right? So all the values, so this is the chi-square distribution. All the values are positive, okay. Suppose, for example, if you want to know, let's say, if you want to know the area left of this, let's say this is, say, what would you say? You say let's say 3.25, okay. If you want to find out the area left of 3.25, and then degrees of freedom is, let's say, n equals to, let's say, 12, okay. So how do you find out that? Is probability that chi-square is less than 3.25 with n is 12 is degrees of freedom will be 11, right? Is you do p chi-square, chi sq, and then 3.25 and then degrees of freedom is 11. That's what you do, okay. So the exactly the same way, just you do p for the area to find out the area of the probability. You should do p, okay guys. So let me do that. So let's do the chi-square thing. So p chi-square, right, p and then chi-square and then 3.25 and degrees of freedom is 11, okay guys. So how much is that? It is, oh, by the way, let me run that. It is 0.01300. That area is 0.0130, okay. So 1.3% area is left less than 3.25. Similarly, let's say if you have, let's say, what is the right area then? 12.25. Let's say degrees of freedom is 11. Okay, so degrees of freedom is same degrees of freedom. So how do you do that? If probably the chi-square is greater than 12.25, let's say. How do you do that? You should do, because always p chi-square, find the area left of whatever number you enter here. So 12.25, it will find out left of. So if you want to find out the right area, let's say if you want to find out that area, you need to subtract the left area, the whole left area from 1. So 12.25, and then degrees of freedom is 11, right? If you do that, what do you get? You get 1 minus p chi-square, right? And then 12.25, and then 11 degrees of freedom. Okay, guys. So if you run this, you will get that is 34.51%. That is basically 0.3451. That's what you get. Okay, guys. So if you want to find out the area between, how do you do that? You will do p chi-square of this minus p chi-square of this. Okay, and degrees of freedom is 11 on both cases. Okay, guys. So if you want to find out the middle area, this middle area, how do you do that? Is p chi-square, because p chi-square always chi-square. Okay, always find out the area left, 12.25, 11 degrees of freedom minus p chi-square, and then 3.25 with 11 degrees of freedom. If you do that, what do you get? So this is what you get. Okay, so that is p chi-square 12.25, and then minus, that is, let me copy and paste, minus this one. Okay, guys, so this is what, this is 64.18. so that will be 64.18%, or in other words, you can guess 0.6418. okay. All right, this is how you find out the area or the probability under a normal curve, t curve, and chi-square curve, okay, or chi-square distribution. So the next thing I want to show you basically is, what I want to show you next is, I want to show you how to find out the critical values. For example, if the left area is given, how do I find out the g value? If the right area is given, how do I find out the g value, and so on. Okay, guys. So suppose, so all these so far I used p norm, pt, p chi-square. Now that is just the opposite. Area will be given you, or the probability will be given to you, and you will be finding out the value of g, or value of x, or value of the chi-square. Okay, guys. So for example, let us say that, let us see the first example. So this is the standard normal curve. Let's say g, what is the g value? Find out the g value if the left area is 0.05. If the left area is 0.05, how do I find out g? So g is equals to, so inverse q norm, and then into that left area is 0.05, and then 0, and then 1. You do that. Okay, q norm. That's how you find out the critical values. So if you want to find out the, let's say, if you want to find out what will be that g value for that right critical, for the right area is 0.02, suppose. So the right area is 0.02, what will be this g value? For that g value, you will do 1, so it will be q norm, right? And then see, so p norm always calculates the left area. Q norm needs the left area to enter here. Okay, so if the right area is 0.02, what is the left area? 1 minus 0.02, right? And then what do you get there? And then 0, 1. Let us do these things. Let me do that one so far we did was probability. Now what I'm going to do next is the critical value. Okay, so let me write down, let me comment it like critical values. Okay, so we can find critical g values, critical t values, critical chi-square values, and so on. Okay, guys. So if the left area, the first one, if the left area is 0.05, you can do q norm and then 0.05 and then 0, 1. Okay, that's what you do. And then if you want to find out the right, if the right area is given 0.02, now if you want to find out the g value for that, then you will do q norm, right, 0.98 comma 0 comma 1, because the left area is 0.98. Okay, so if you run that, you get negative 1.64. If you run the other one, you'll get 2.05. Okay, the first one is negative 1.64, so equals to, oops, this one equals to negative 1.64, and the other one is 2.05. This is what it is. Okay guys, sometimes the middle area will be given to you. Okay, so for example, let's say sometimes a middle area will be given to you. Suppose if the middle area is 80%, what will be the G value, G1 and G2? That will be asked like that. Okay, so to find out the G1, what is the area on the G? So the middle area is 80%, so the outside area will be 20%. So half of the 20% is 10% here and the 10% here, right? So to find out G1, how do you find out G1? G1 will be again Q norm, because if you are asked to find out G values or T value or the chi-square value, always use Q. If you are asked to find out the probability or the area, always use P norm, okay, or PT or P chi-square. Q norm, left area is 0.1 and then 0 comma 1, and G2, let's say that G2, that is G2 there, you want to find out that is G2. Okay, you want to find out that G2. So to find out G2, you do Q norm. What is the left area? Left area is 80% plus 10% will be 90%, right? So and then 0 comma 1. So let us find out what are these values. So you do Q norm, and then 0.1 and then 0 comma 1. The mean is 0, standard deviation is 1, and the other one is Q norm 0.9, right, 90%, and then 0 comma 1. And if you run the first one, what do you get? You get negative 1.28. The other one will be positive 1.28. Okay, because this is symmetrical, so 0 is in the middle, that's why. So this will be negative 1.28 and then this will be positive 1.28. So this is how we find out the critical value for the G. Exactly the same technique we use for chi-square and for T. Okay, for example, for the T distribution, if you have the left area, let's say left area is, let's say 1%, okay, 0.01 is the left area, and let's say n equals to 11. Okay, so what is the degrees of freedom? Is 10, right? N minus 1. So if you want to find out, let's say this is G, then you do G equals to QT. Instead of PT, we use QT because you are asked to find out G. So QT 0.01 and the degrees of freedom is 10. Okay, so let us do that. So if you do that one, so you do QT, okay, and then left area is 0.01, degrees of freedom is 10. Okay, if you run that, then you will get negative 2.2638. You get negative 2.2638. Okay, so similarly you can find out the one, you can do 1 minus for the right area. For example, if you want to find out that G value, G2 values for the right area 0.03, let's say. Okay, so what will be G2? G2 will be QT. What is the left area? Always enter the left area on QT. Okay, the right area is 3%, so the left area will be 97%, and then mean is, so the degrees of freedom is 10. So if you do that, what do you get? So because I'm taking the sample size that, so you'll have QT, right? So QT and then 0.97 and then 10 degrees of freedom. So if you run this, what do you get? You get run that one, you get 2.12. That is the value of 2.12. What does that mean? This value is that one, right? So that will be negative 2.2638. This will be positive 2.12, and so on. Similarly, if the middle area is given, exactly the same way you can find out. Okay, for the chi-square distribution, what we do? Q chi-square. Okay, for example, let us say that suppose this area is given to you, the right area is given to you, and you want to find out chi-square right here. Okay, how do I find out the chi-square right? Suppose this area is 0.02 and you want to find out the chi-square right value. How do I find out that? Is chi-square right equals to, what is the left area? Left area will be 98%, right? 0.98. What do you do? And then let's say n equals to, let's say 19. Okay, what is the degrees of freedom? Will be 18, right? So chi-square right equals to, so what is the left area is 98, so you do q chi-square, and then left area is 0.98 and the degrees of freedom is 18. Okay, let us find out that. So chi-square, that is a q chi-square, and then 0.98, and then degrees of freedom is 18 because the sample size was 19. Okay guys, so if you run that, you will get 32.3462. that is 3462. Similarly, if the left area is given, you can do the same thing. If the left area is given, you do chi-square and q chi-square and then left area into the left area. If the middle area is given, exactly the same way. Okay guys, so what I mean here is, if you are asked to find out the area under the curve, or if you are asked to find out the critical values, okay, if you are asked to find out the critical values, or if you are asked to find out the area under the curve, then you can use P or Q of the corresponding distribution. Okay guys, all right, so this is basically the review of what we did last time. Okay, all right, so what I'm going to do next is, let me talk about sampling distribution. What do you mean by sampling distribution, or sampling distribution of mean or median, mode, standard deviation? So what does that mean? That's what we are going to talk next. Okay guys, so sampling distribution of sample statistic with fixed sample size and sampling with replacement. What does that mean? That means, so what do you mean by sampling distribution is, suppose I want to, let me tell you about sampling distribution of mean. Okay, you can find sampling distribution of other statistic like median, mode, or standard deviation, variance, proportion, anything you can think of. Okay, so what does that mean is, for example, I want to know what is the average age of the people. Okay, average age of the people who got the Moderna vaccine, let's say, okay, for COVID-19. Okay, so you want to know the average age of people who got Moderna vaccine in January. Okay, you want to know that in the whole population inside the United States. But if you go to each hospital where the vaccine providers where they get the vaccine and then collect the data, it takes a lot of time. So what you want to do is, you may want to go one hospital from one state, another hospital from another state, another hospital from another state, and collect the data like that. Okay, so for example, if you go to a hospital in Georgia, okay, if you go to the hospital in Georgia, and then let's say you find out the average there. Okay, average age, let's say you got, let's say 53. Okay, you go to another state, let's say Tennessee, and then you find out the average age of the people they got in a particular hospital there is, let's say 46. Maybe the healthcare provider will getting those vaccines in January, right? Suppose that you went to another hospital in Georgia, let's say Georgia 2, and you find out X bar equals to let's say 65, and so on. So from that population. Okay, so if you continue doing that, now what you are going to do here is, you are going to make a distribution. So you make a distribution table, and then you see that, let's say this is the sample means, right? So these are like X bar. Okay, Okay, so let's write down 40. The smallest one were 40. So how many samples had mean 40? Let's say there were 5 samples had mean 40. Okay, how many samples had mean 41? Let's say 7 samples. How many samples had mean let's say 42? There were 12. How many samples had mean 43? Let's say 17, and so on. You make this table. This is called the sampling distribution. Okay, sampling distribution. By the way, I forgot to tell you that when you collect a sample, one sample from a particular hospital, you need to collect the data. I mean, you may be collecting only some data from there, not all the data, only some data. Okay, when you collect a sample from that hospital, try to pick the same size sample from each of those samples. Okay, same size, same end. Okay, samples. Okay, so in that case, let's say that 5 samples had 5 samples of those. What does that mean? Because you are keeping all those things. Maybe you are collecting 1,000 samples there. Okay, so on the first sample of 30, you got 53 average. In the second sample of 30, you got 46 average. In the third sample of 30 people, that's what I'm saying, your average is 65, and so on. And now what you are doing, you are writing in a table to see nice in the nice format, right? So suppose that there are 5 of the samples have mean 40, 7 of the sample have mean 41, 12 of the sample have mean 42, 17 of the sample have mean 43, and so on. Okay, now, so this is called the sampling distribution. Okay, now, so sampling distribution of the mean is you are collecting the mean of each of those samples. Sampling distribution of the proportion means you are collecting the proportion from each sample. For example, what proportion of the male were there? What proportion of the female were there? What proportion of the nurses were there? Doctor were there? So you can think of anything there like that. So you collect the sample and find the proportion there. Collect another sample, find the proportion. You need to replace back if you are collecting from the same locality. Okay, so you can do that like many times and make a table like that. That will be the sampling distribution of the proportion. Similarly, if you find out the variance of the age of the people who are getting the Moderna vaccine in the January, then you can find out the variance of a particular sample, find the variance of the another sample, find the variance of the another sample, and then make a similar table there. Variance, and then how many of those samples have that variance, and so on. Okay, guys. So that is called the sampling distribution. All right, next. Look at this, what it says. Sampling distribution of sample mean is normally distributed. This is the sampling distribution of the mean, right? If you plot this, what it says is, if you plot this, so let's say this is 41, 42, 43, 44, and so on. It says that if you draw that sampling distribution, you will see that normally distributed there, meaning that it will be bell-shaped. If you go from the middle of those, right, it is like a bell-shaped curve. That's what it is saying. Okay, guys. So it will be a bell-shaped curve. That's what this says. What will be the mean though? So the mean of the sampling distribution will be same as the mean of the whole population. Okay, and the standard deviation of the sampling distribution will be a little bit smaller. The standard deviation will be sigma, population standard deviation divided by the sample size. That will be the standard deviation of the sample mean sampling distribution. Okay, it is called standard error. Standard error is the standard deviation of the sampling distribution is called the standard error. Okay, for the mean, sample mean, the sampling distribution is normally distributed. Okay, with the mean equal to the population mean and the standard deviation equal to sigma over root n, which is smaller than basically the standard deviation of the population. Now, this is called the standard error. Okay, CLT. Do you remember the central limit theorem from the statistics class? What it says is, when you collect the sample for the sampling distribution, if the sample size is big enough, then the even if the original population is not normally distributed, the sampling distribution will be normally distributed. Okay, if the original population is normally distributed, then it does not depend on the sample size. The sampling distribution will be normally distributed whatever sample size you take. But if original population is not normally distributed, then the sampling distribution of the sample mean will be normally distributed when we take a bigger sample size, when we increase the sample size. That's what the central limit theorem says. Similarly, the sampling distribution of sample proportion will be approximately normally distributed. It will be approximately normally distributed, where the mean of the sampling distribution will be equal to the population. The mean of the sampling distribution of the proportion is equal to the population proportion, and the standard error for the proportion is that p hat means sample proportion times 1 minus p hat over n root under. Similarly, the sampling distribution of the sample variance is right skewed. It is not normal distribution. The mean of the sampling distribution is equal to the population variance, and the standard error is this. So the average of the all sampling distribution, of the variances will be equal to the population variance, and the standard error will be sigma square over times 2 over root under n minus 1, assuming that the original population is normally distributed. Okay guys, so let me stop this video right here. So I hope that you guys understood what is the sampling distribution of mean, proportion and variance, and how does the distribution look like. Okay, and then what are the standard error in that case. All right.